So today's lesson we're going to be looking at fog. So for fog to occur, the saturation point must have been reached either by cooling or the addition of water vapour to the atmosphere. And for visibility, it has to be less than 1,000 metres due to suspended water or ice crystals in the atmosphere in contact with the ground. And this first fog we're going to look at is radiation fog. And it's caused overland by the ground cooling by radiation and slow moving air in contact with that ground being cooled by conduction to below its dew point. So looking at that then, we see we're going to start off with its formation. So we need moist air, we need that moisture content. That's what's going to cause our fog. And we need clear skies. We need the clear skies because that's what's going to allow that air to cool. If we had a cloud cover, it effectively insulates it, and then that's going to prevent that fog from occurring. We need a long cooling period, so that obviously going to make sure the air cools down much more, which is what's going to take it past its dew point. And we need a little bit of mixing, so we need light wind. If there's no wind to mix it, it's not going to cause it to occur. And same again, if the wind's too strong, it's effectively just going to disturb it and blow it away, which is why we say about 2 to 8 knots. We can also, although it's not necessary, have it in low-lying ground. So again, if anyone goes into the countryside and valleys, you can often see you're going to get fog in that low-lying ground as well, as that cold air sinks. And it can be up to anywhere about 500 to 1,500 foot thick. How is it going to clear? So we can think about it. If we have a drier air mass that comes in, so that air moves through, and it's going to clear it up because it's now got no moisture to cause that fog. We talk about cloud cover. So effectively, it's going to insulate it and warm it up because those rays can't escape as they come through. They come down and bounce up like this, and therefore warm that air. Solar radiation, so effectively heating it up, that's going to warm that air up and therefore take the temperature of that air above its dew point. And we talked about it, if we've got increased wind, it's effectively going to blow that fog away. That is radiation fog, nice and simple. The next one, advection fog. So it's caused by air being cooled below its dew point by a moist air flowing over a cold surface that has a temperature below the dew point of the air mass. So simply, if it's easy to think about, if you've got our sea, we've got that air, which that sea is going to be colder, so that air is getting cooled down by it. It can occur over land in coastal areas, or if you've got a mild spell follows a prolonged frost or substantial snowfall, so our ground's much colder than it normally would be. The wind we're looking at about 15 knots to keep it flowing, and it'll be about 1,000 foot thick. And a great area to see this is the Isle of Wight, around the south of the Needles and Catherine's Point. So looking at the formation, we've talked about that warm, moist air. So thinking about that tropical maritime air coming through with a dew point of about 11 degrees and that moderate wind blowing it for north. So as that tropical maritime air comes north, it's being cooled by that colder water below it. So you see our temperature is reducing as it comes north. And then that's what's going to give us that advection fog over that southwest corner of the UK. Looking at clearance, so again, that solar radiation or that warming up. We can have a drier air mass coming in, so if we've got a tropical continental or polar continental, that drier air mass takes that moisture away, can't form the fog. And also that change in wind direction as well can affect it. And that is advection fog. Looking at hill fog. So it's cloud covering high ground and it's caused by adiabatic or upslope cooling. So the air has been forced to rise by the ground, and you can see it's cooling. And as it cools, it's going to reach its dew point and form cloud over the hill. It can be also caused by movement of low cloud onto the hills. So as it descends, it covers a hill. It's dispersed by the movement of the cloud or lifting due to solar heating. So if you've got that air mass, that air moving, it's going to move away from that hill, or that solar radiation is going to warm it up. Frontal fog. So frontal fog, it's going to occur predominantly again over those high grounds, and it's going to form near to the front due to the lowering of the cloud base in the rain and the mixing of that moist air masses at the different temperatures. So when you look at fronts, we know this is where our band of weather is, and that's where we're going to get that frontal fog. It's effectively dispersed by the movement of that front, and that changes it to a drier air mass as it occurs. Some other fogs we need to think about for EATPL. So Arctic smoke, basically a cold air moving over a warmer surface. For example, Norway. The surface is really, really cold, and that air is actually warmer. We can also get smoke fog or smog. We get predominantly near industrial areas, large towns. The conditions similar to radiation fog, and it's dispersed by the convection, increased turbulence, or wind speed. And those are our fogs, nice and simple.